Hello guys, welcome to a new video, and in this video, as you can see, there's a lot of stuff going on in this topology, but what I'm configuring is I have configured already on router 2 with OSPF and this loopback address. I also configure this interface over here. Router 3 configure the same loopback addresses with ERGRP. These two links over here are running ERGRP. Configure RIP version 2 with the loopback addresses. Put the loopback addresses in RIP version 2. Configure this interface. And also router 5 with BGP, these loopback addresses over here. And configure that interface with BGP. Let's see what else. One thing that I forgot to do in router 5 was do the neighbor. So I'm gonna have to do that before I start. But in this video, let's see what I have over. I want to authenticate MD5, so ERGRP with MD5. We are going to configure that. We are going to redistribute version 2 into OSPF, ERGRP, and BGP, OSPF in RIP version 2, ERGRP, and BGP. So we are going to do all that redistribution into each one of the routing protocols. We are also going to block this network right here with a distributed list, and then we are going to block another one with a prefix list, and then we are going to change the next hop for 55555 with route maps. So that's all that we're going to cover in this video. So let's go ahead and start since I have a lot to do. And first, like I said, I forgot to finish that BGP configuration in router 5. So let's go to router 5 first and do a neighbor 50.50.50.1, and then the remote autonomous system that we're going to use is 12.13. All right, great. You can do an end right here. Now let's go ahead to router 1, and from router 1 is where we have to configure everything. Configure T. You can give it a host name of R1 for this one over here. The first one that I want to configure is going to be OSPF. So let's go ahead and configure OSPF. Interface gigabit 0/0, which is this interface connected to router 1, right? Router 1 right here. IP address 10.10.10.1, 255.255.255.2. Now shut down. Now should be able to ping router 2. There we go. I'm able to ping router 2, so that's great. Let's go ahead and configure OSPF then. Router OSPF. Oop. OSPF. The network is 10.10.10.0, and it's going to be in area 0 as well. Oops, area 0. There we go. Now there we go. Now we have form and neighbor relationship. If we do show IP neighbor, do show IP, oh, SPF neighbor, actually. There we go. We have a designated router. Over here, router 2 has become the designated router. The router ID for that, or the neighbor ID for router 2 is 3.3.3.3, which is the highest loopback address. All right, so that's good. We have form and neighbor relationship. Now let's go to router 1. And in router 1, we have to configure these two interfaces with ERGRP, and which is gigabit 02. So let's go to interface gigabit 02. And gigabit 02 IP address is the 20.1.252. Now shut down. Now let's do gigabit 0/1. IP address of that is 30.30.30.1. 252. No shutdown. For gigabit 01, I have to configure the bandwidth to be 128, and for 02, the bandwidth has to be 256, and I'm doing that so I can show you later on. I'm going to do the next hop, I'm going to change it. So that's why I'm doing that. You guys are going to see why I did that later. And now let's go ahead and configure router ERGRP 1. The network for that is 20.20.20, 255. The other network is 30.30.30.30, 255. All right, there you see we have form neighbor relationship. with the two links. So if you do show IP EIGRP neighbor, you see we have two neighbors on Giga 01 and 02 is the same router. Just because we have configured on both interfaces, they are different. All right, great. So we have OSPF and EIGRP configure. Now let's go ahead and configure RIP version 2. And RIP version 2 is going to be on Gigabit 03, and the IP address of that is 40.40.40.1/30. Let's go to no shutdown. Let's go to router RIP. Let's do version 2, no outer summary, right? And then let's go ahead and add the network 40.apps. There we go, that's good. So now if you do show IP route, if you do RIP, it should only show you the RIP route. And since RIP doesn't tell you whenever it forms a neighbor relationship, I just did a do show IP route RIP, so it can show me the route to RIP. But if you do show IP route, it should show me OSPF, EIGRP, and RIP. There we go. The two RIP routes, 7 and 8, are there. The three the EIGRP 4, 5, and 6, and the three OSPF 1, 2, 3. All right. Now let's go ahead and configure BGP. Right. So let's go to interface gigabit 0/4 IP address 50 50 51 252. Now shut down. Now let's go ahead router BGP autonomous system 1213. Right. Yep, that's what I have configured right here. Let's do our network 50.50.50.0. Actually, not like that. Okay, mask 255.255.255.0. This is not a wildcard mask like European OSPF. Now let's do a neighbor. The neighbors has to be the IP address of our neighbor, which is this one, and then the remote AS is the remote autonomous system or router 5, which is 1214. And nothing, nothing, nothing. There we go. We have form and neighbor relationship, BGP. So if we do show IP BGP neighbor, you can see our neighbor relationship 50, 50, 52. All right. And also we should now see if we do show IP route BGP, we should have the two routes 9 and 11. We show the loopback addresses that we have configured. All right. So that's great. We have, if we do and show IP route, we have route to OSPF, EIGRP, RIP, and BGP. And then we have some local and directly, directly connected routes. Sorry for that. All right, there we go. Here's our big um, routing table that we have right now. And let's see what we're going to start with. So the first thing that I want to do, I want to authenticate Gigabit 02 with MD5. All right, so let's go ahead and start with that. From router 1, you need to config T, and you need to do a key chain. The key chain that I'm going to name, I'm just going to name it CCNP. The key 1 key string. The key string over here is going to be just my name. Great. So the key chain has been configured. So let's go ahead and exit. Then let's go ahead to interface gigabit 0/2. All right, and let's go ahead and assign that IP authentication, right? And the mode, EIGRP, autonomous system 1, MD5. And now as soon as I do that, the EIGRP authentication has been configured. And since that has been configured, and router 1 is now asking for a keychain, and router 3 does not have a keychain, the neighbor relationship went down. All right. So we, we need to also finish. Let me go and finish authentication, keychain, the keychain EIGRP autonomous system 1, and the keychain that we name, it was CCNP. So let's go ahead and configure that CCNP. and P. Great. Now let's go ahead to router 3 and do the same on gigabit 0/2. All right. And there we go. It is saying that it has failed because it cannot authenticate right here. Authentication failure. So let's go ahead and do that. Exit key, so a keychain, call it CCNP, key one, key string. Let's call it my name as well. Oops. Key string asker. Let's go ahead and interface gigabit 0/2. Let's do IP authentication and mode EIGRP 1 MD5. IP authentication and keychain EIGRP 1 CCNP, right? I think I got that right. Yep, CCNP. There we go. And you can see now that the neighbor relationship came back up for neighbor 2020-21. All right. So now we are authenticating EIGRP on gigabit 0/2. So that's good. That's being done. Now, the next thing that I want to do, I want to redistribute RIP version 2 of SPF, EIGRP, and BGP. So let's go ahead and do that. And to do that, we need to do it from router 1 because router 1 is the one that has all of them running at the same time, right? Router 1 has OSPF, EIGRP, version 2, and BGP running at the same time. So we have to redistribute from here. And what redistribution does is that it acts as a translator for these dynamic routing protocols. So if EIGRP wants to communicate with RIP, right? If it wants to get this RIP, the routing tables that RIP has, it doesn't know how to do it, and therefore we have to configure a redistribution for them to be able to do it. So router is actually going to act as the translator because router one knows how to learn, knows how to communicate with OSPF, EIGRP, RIP, and BGP. Now we are just going to configure to be a translator so we can get OSPF. So OSPF can get EIGRP's routes, RIP routes, and BGP's routes. Okay, and EIGRP is going to have OSPF routes, RIPs, and BGP, and all of them are going to have other routes. Okay, in the routing table. So let's go ahead and do that. And because let me just show you so you guys don't get confused. If you do show IP routes, you can see that we only get um, directly connected routing tables or directly connected routes or local routes, right? The local routes are the one that the router has, and the connected routes are the ones that are connected with router 2. Like router 1 is the one that has um, these IP addresses, okay? So therefore, what I want to do is I want to insert or redistribute um, EIGRP routes into OSPF. Okay, so I'm going to go ahead and do that, and you guys are going to see that. And even though you can do a debug IP routing, let's turn that on. So we are going to debug IP routing. So whenever we get anything in this routing table, you guys are going to see it. So let's go ahead and configure that. Let's go to router. Let's configure OSPF 1 first. And we are going to redistribute. And what are we going to redistribute? We are going to redistribute. First is going to be EIGRP. Which autonomous system are we going to redistribute? I want to redistribute autonomous system 1, and the metric is kind of like how far the metric are or how far it is. So we're just going to leave it at 2, and then we are also going to do subnets. All right, so that's great. We have anything here? Nope, nothing yet. There we go. As you can see, since I did this command right here, redistribute EIGRP, autonomous system 1, metric 2, subnets. You can see now when I turn on the debug IP routing, you can see now that um, at this time it was updating OSPF with this routing table, with this network, with this network, with this network, with this network, and with this network. And where did that came from? Well, if you go ahead and see on router 3, you can see that router 3 is the one that has the 4 network, the 5 network, the 6 network, the 20, and the 30 network. And that's the one that we just got. And if you go to show IP routes now, you can see now that we have this OSPF E2. What is OSPF E2? Well, if you come up here, OSPF E2 is an external type 2. If I'm able to find it, let's see. Here we go. OSPF type 2. So this is coming from an external source, right? So it is an OSPF route that is coming from outside with an E2. So it is coming from EIGRP. Now, let's go ahead and do another one. Let's go ahead and redistribute RIP. All right, and let's wait for RIP to come. There we go. So now we are redistributing RIP, and you can see that we have updated, uh, and we have added the 7 network, the 8 network, and the 40 network, which is what RIP version 2 has. So if you do now a show IP route, you should have a lot more routes in here. There we go. And that's how you redistribute routes. Easy enough, right? Now let's go ahead and do, I think BGP is the same way. Let's see, BGP. Oh, it's going to ask me for the autonomous system. The autonomous system that I want to add is 1214. 1214, yep. Metric, let's have it at 2. Subnet, that's good. BGP is running autonomous system 1213. Oh, so we gotta add 1213 over here. That's what it is. I added the wrong one. I added the one that was over here. We have to add the local one. There we go. And now, as you can see, we have added more. We have added the 9 and the 11 network, right? And let's go ahead and do a show IP routes now again. And you can see that we have routes to everywhere. But why isn't it the 50 network showing? Let's go ahead to router 1 and do it router BGP 1213. I don't think I ever added the network. If I add the network 50.50.50.0 mass 255 255.255.0. Did I add that there? I think I did, just to make sure. Let's go ahead to router 5. Show run the because I think this should be showing over here, but it is not showing. Let's see if we do to the show to the wrong command from here. Gigabit 04, good. BGP. So BGP has it over here. So weird how it's not showing it over there, but well, it's fine. So let's go ahead and continue now. Now what I want to do is I want to redistribute EIGRP, or I want to redistribute all the routes to EIGRP. Since we already did it for OSPF, now we have to do it for EIGRP. It is a little bit more complex, if you say so, than OSPF because EIGRP uses a different metric than OSPF. OSPF it uses the Dijkstra, I think that's what it's called, and it's a little bit simpler than EIGRP. EIGRP uses a complex calculation because it also uses the K values, um, which are 5 different values. The first one being bandwidth, second one being load, third one delay, fourth one is reliability, and the fifth one is MTUs. So we actually have to put in all those numbers for that. So let's go ahead to router EIGRP, um, EIGRP1, and first what I could do is for the metric I could just go ahead and put all the metrics right here, right? I could just manually input the metrics and just have it whenever I configure, just use this metric for every single one of them, right? Since they're all like one hop away, they all should be identical, right? So what I want to do is I want to configure the metrics. Um, let's do weights. Let's actually not. Now let's not do that because then I would just because this one has 256 and 128. Let's just redistribute um, the same way that I did it with OSPF. So let's go ahead and do redistribute. Let's do OSPF, and then the process ID for OSPF that I want to redistribute is 1. We are going to use metric, and the metric now is going to ask me what is the bandwidth in that um, gigabit 0/0. Like it's going to ask me what is the bandwidth. Well, I do not know that, so let's go ahead and do do show IP interface gigabit 0/0, right? So from here we should be able to see the bandwidth, maybe. Nope. Let's go ahead and do show IP. No, just do show interface bandwidth. There we go. So now you can see the bandwidth over here. The bandwidth is this. So if you do a redistribute OSPF press ID 1, the metric, the first one is going to ask me is the bandwidth. So we can go ahead and copy this and paste it over here. Oops. There we go. That's the bandwidth. Now it's going to ask me the delay. What is the delay? You can see right here, delay is only 10 seconds. So let's go ahead and add delay 10 seconds. The reliability should be 255. There we go, 255. So let's go ahead and add 255. The next one is going to be the loading. The loading should be 1. There we go, 1. And the MTU should be 1500. Where is the MTUs? I can never find the MTU. Here we go, 1500, like I said, 1500, right? And you can just go ahead and just press enter. And now if we go to router 3 and then show IP route, you can see now that we have some external IP addresses. We have this one right here, which is the DX. And if you come over here and take a look at it, and you see that the EX is an external, um, it's coming from an external source. And if you see right here, 1, 2, 3, and the 4 network, and also the 10 network are coming from OSPF. Really nice, right? How redistribution works. So now let's go ahead, keep going, keep adding more. Let's go ahead and add, let's go ahead and add RIP. And then after RIP, let's go ahead and add BGP, and BGP, remember, is 1213. There we go. Now if you go to router 3 and do a show IP route again, you should have a lot more routes. As you can see, we have the 40, the 20, the 11, the 10, the 9, the 8, the 7, the 1, 2, 3, and the 4 network in there. All right. So now we have redistributed. Now the next one that we have to do is RIP version 2. So let's go ahead and router, skip and moving, router RIP. All right, let's go to version 2. This one is a little bit easier. Redistribute. What do you want to redistribute, my friend? Let's redistribute EIGRP. EIGRP, what autonomous system do you want to do? 1. And let's do metric 2. And then that's it. And then let's do OSPF as well over here. OSPF. And then let's do BGP. BGP is 1213. Great. Now if you go to router 4 and show IP route, you can see that for actually for RIP, it doesn't show any external. It shows that everything is just an R, right? Everything it shows it with an R. Like you saw on router 3 and router 2 that it was showing the D and the X, which meant that it was coming from an outside source. For this one, it doesn't tell you where is that it doesn't tell you that it is an outside source or the inside source. So that's just RIP. That's why nobody uses it anymore. That and because of the hop count. Yep. Okay. So we have redistribute into OSPF, EIGRP, and RIP. Let's go ahead and see if we can do it for BGP, right? BGP 1213. And let's go ahead and redistribute. What do we want to redistribute? Let's redistribute EIGRP, autonomous system 1, using the metric. Metric of 2. There we go. And then let's do OSPF, OSPF1, and then let's do RIP. There we go. And now if we go to router 5, we should be able to see all of those. So show IP routes. And as you can see, BGP is giving me the 4, the 5, and the 6. the 20 to 30 network. All right. Okay, so now let's keep moving. Let's move up. Let's keep moving and let's go ahead and do. Okay, so we have done with the redistribution. Done. You guys know how to do that now. Now let's go ahead and block the this network, the one with a distributed list. All right. So I wanted to block it from router one because if you go show IP routes, this network, I do not want that network. I don't know. I just don't like the one network and therefore I just don't want it there. So if you do show IP routes, one, you can see everything you need. You can see that the routing entry is 1.1.1 slash 32. It's coming from OSPF1, the distance of 120, metric of 2. The type is intra area. It is distributing via ERGRP1, RIP, and BGP 1213. It's being advertised by ERGRP metric. With this is the bandwidth. Um, this is the what is it? The delay, reliability, and all of that. So since I do not want, I just don't want it in my routing table. So what could I do for that? Well, what you could do at a distributor list. You could remove it by using a distributor list with an access list. So what you need to do is create an access list first. Let's create a 102, and we want to just go ahead and let's go ahead and deny it. And I want to deny, and then over here it's going to ask me like, what do you want to deny? I want to just deny an IP. Source, what is the source? Where is it coming from, right? Where is that coming from? And as you can see right here, it is coming from 10.10.10.2, which is this IP address. So let's go ahead and add 10.10.10.2. Even I can just add over here host 10.10.2. And then after that, what is this? Like, where's, so this is the source. Yeah, where is it coming from? And what is the destination? Like, which one is the one that you want to block? So I want to block 1.1.1.0 and then wildcard of 00255. That's the one that I want to block, okay? Oh, that's great. And where do you want to block it though? Like, how? From where? Well, I want to block this from OSPF because that's the one that is sending me this route that I don't want. So we have to go ahead and go to router OSPF first ID of 1, and then we gotta go to the Distributelist, and for here it's going to ask me what is the access list number that we have configured for this. So I have configured the 102 access list. How do you want to filter? Do you want to filter coming in or coming out? Well, this route is coming in gigabit 0/0. So I wanted to filter going in, right? And where do you want to place it now? I want to place it on gigabit 0/0 because it is coming in that way, right? It is coming from router 2 into router 1. So there you go. And now if you do show IP route, oops, it looks like I blocked all the OSPF. So what did I do over here? Coming from 1.1.1.0, access is denied. Okay, so this is what happened. Because remember you have to be careful with this config T. You need to do a IP. You need to permit after that. Remember you have to permit IP any because it blocks everything at the end. So if you don't do that, you won't be able to get any uh, it's going to block everything. So if you do now I show IP routes, now you can see that the 2 and 3 network are showing. All right, because remember, every time you do a um, create an access list, at the end it's going to unite everything. So you need to permit the network. So if you do n show, if you do a show access list, you can see that we have 2 matches already, right? And also 2 more matches to allow. So we have allow the 2 and the 3 network. So that's why we have two matches. And then I think two matches because I had to reconfigure the access list, so we were able to get the 2 and the 3 network. So that's how you filter or block a network using a distribute list. So now let's go ahead and block for that 4 with a prefix list, which is a little bit better and a little bit nicer than a distributor list. Um, so let's go ahead and let's go ahead and do that, guys. From router 1, we want to block the 4 network, and that's coming via EIGRP config T. Let's see if I remember this, guys. So, okay, IP prefix list, and our prefix list works the same as a distributed list. It doesn't work the same, but it does the same job. It is a way to filter traffic on unwanted traffic, like the one network that I just didn't want there. IP prefix list, it does the same job, but a lot better and without access list. Prefix list has its own access list. So you're gonna see so new, and like it's going to ask you like what do you want to do, right? Like what is it that you want to do? You want to deny, add a description, permit, add a sequence number? No, I don't want to add a sequence number. I want to deny, and then it's going to ask you, okay, man, like what do you want to deny? I want to deny the 4/24 network, right? And then it's going to ask you like, okay, so you want a minimum prefix length to be matched, or do you want a maximum prefix length to be matched? And what I want to do is I want to do a LE less than equals to 32. And what that means is that we are going to block from the 24 subnet all the way to the 32 network, right? Or you could also write it like this, GE 25, which means that it's going to block from the 24 all the way to the 32 network because it's greater than equal to. So if it's greater than equal 25, I also want to block. So you're going to block the 24, the 25th because it's equal, and then anything after that because it's going to be greater than 25, it's also going to be blocked. So I just want to leave it as LE 32 because it's going to block everything that's equals to 32 and everything that's less than 32, less than equal 32, right? So let's go ahead and leave it like that. Now, where is this network? It is in EIGRP because EIGRP is the one sending it to router 1. So let's go ahead and do router EIGRP 1 and be careful. You have to make sure that you're using the same autonomous system where it is configured. Otherwise, it won't work. So now we have to do a distribute list. It's the same distribute list, but now we want to use a prefix, right? Prefix. And what is the name of the prefix? That we name it new. So let's go ahead and EW. I'm going in and where? Where's that interface? I want it on gigabit 02, right? And also gigabit 01 because it's coming via both ways. So now if we do a do show IP route, oops, do show IP route. There we go. Hmm. It is blocking, as you can see, it is blocking all of it's blocking everything, just like the access list, huh? So what you need to do is, let's go ahead and from here, then let's do permit IP prefix list new. Okay, so let's go ahead and exit out of here. We want to also deny, you want to permit, and what do you want to permit? You want to permit every single network. SN equals 32. Now it should be resyncing again. Do show IP route. The D network are still out. Okay, there we go. It is resyncing again. Show IP route. There we go. All right. So the routes are back in. I forgot to because prefix list works the same as the access list. it has that deny at the end that denies everything. So you have to, well, after you deny one of the routes, you need to allow everything else, right? Because you're only denying that one thing, right? Or what you could do is allow the 5 and the 6 and just leave it like that. But since you are denying, you have to allow whatever you want in. Otherwise, it won't work. Okay, so that's how you could block with a distributor list or filter with a distributor list, and also how to use a prefix list, which is a lot better because it does not use a access list. And because I hate access lists, by the way, too. All right, so let's go ahead and change the next hop for 5.5.5 with route maps. So let's go ahead and configure route maps, which are really cool, right? So if you do a show IP route, BGP, EIGRP, show IP route BGP, and as you can see is that I want to configure the 6.6 network to go via, instead of 20.20.20, 20.20.22, right? I want it to go to the 30.30.32 because it is able. If you go to show IP, EIGRP, topology, you're going to see that the 6 network is able to get there via the 20.20.22 and 30.30.32. So I just don't want it to take the 20.22. I want it to send it 30.32, and that's what we are going to use with the that's what we're going to use with route maps. The route maps lets you do all of this stuff. So if you go to route maps, right, from here you have to name it. We're going to name it next, right? And then what is it that you want to do? I want to permit this traffic, right? And the sequence number, we're not going to worry about that. So now we are into the configure route map. After this, it's going to ask you like, what do you want to do? So first, I want to oops, let's go ahead and exit out of here first. Let's go ahead and configure an access list. This one we need an access list for, so let's go ahead and 50. And we want to permit, and we want to permit a host, and the host that we want to permit is the 4.4.4.0. Actually, not the 4.4.4, the 6.6.6.0, 255. Actually, the host 6.6.6, there we go. Now let's go ahead back to route map, next permit. And what do you want to permit? Well, I want to permit this IP, and that IP, where is that IP coming from? Let's see, match IP. Let's see if I remember. It's a lot of stuff right now in my mind. Okay, let's see, match, and let's just do from here. Continue, set, match the values from the routing table, right? And my mouse just died, I think. Yes, it just did. Give me 1 second. That's because I never turn it off. That's what happens when you never turn it off. There we go. We're back. We're back. We're back. Okay, so route maps, guys, match values from routing table. So let's go ahead and match. And we're going to match an IP, I believe, address, right? And now, after you do IP address match, it's going to ask you for an IP access list number, and the one that we configure, remember, was 50. There we go, access list 50. So let's go ahead and do 50. Okay, done. You can do a range of IP access lists if you want to, but I only have one, and it is 50. And now after that, you need to set, like, what do you want to set? Do you want it to actually set the IP address? Hmm. Let's see. I think I'm getting confused. So set DV. Okay, yeah. No, I got it right. So you do the set IP next IP address Okay, IP next hop. So the next hop of the IP address, I want it to be 30.30.30.2. And remember, guys, that before it used to be, if we go up and if I find it, um, for the 6 network, it used to go to the 202022. And you can also see it over here. It was going to the 202022, and I'm saying no. I don't want it to use the 202022 network. I don't want to use Gigabit 02. I want to use Gigabit 01. Even though the bandwidth is 128, I don't care. Yeah, your IP. I want to send it to the 30.30.30.2 network, right? So let's go ahead and do that. Now, if you go in and if you do ping, or not a ping, let's do it a trace route to 6.6.6.6, and it's still sending it via 202022. Okay, and that's because config T, you need to go to interface gigabit 0 slash 0/2. Let's see if you do on 0/2, and if you do an IP, then right here you can do a route. So no route maps. So if I do an IP, okay, I'm really forgetting something. IP, not an IP address. It is an IP route maps. Note prefix. No. All right, I'm giving up. So let's go ahead into my notes because I'm human and I forget a lot of stuff. If you go to CCNP, let's go ahead to filtering routes. These are my notes prefix list. BRF. Now this one, it is, yeah, it is this one, policy-based routing. So you set it, and then you go to IP policy. That's why I was never gonna remember that. So you need to go to IP policy, policy route map, and then the name of it that we name it was next. There we go. Now let's see if we do trace route 6 network. Still going the same way. What if we go one next? It is still taking me via the 20.20.6 network. Interesting choice. Why is it doing that? I believe because I have to do this from. Okay, okay. So now it is actually working. Uh, if I do it from here, let me see if we do. Okay, next. Let's go ahead and implement it in 4, and let's do route maps next. So now if we actually do it from Gigabit 04 right here, this one, when it comes in, then it's going to send it to the 30.30.2 network. So let's go ahead to router 4 and do a ping 6.6.6. Or not ping, let's do a trace route 6.6.6.6. And even though it is sending it this way, okay. So what I'm going to do, guys, I'm sorry for that. What I'm going to do is I'm going to then go over my notes again. I guess I forgot how to use a route maps um, by setting the next hop. So what I'm going to do is in the next video, I'm going to do a bunch of videos on route maps until I get it right. So thank you guys for watching, and I see you on the next one. And remember, guys, if you have a Twitter account and do not following a lot of guys, just go ahead and follow me on Twitter at CCNA Daily Tips. And if you don't have a Twitter account, I'm sorry for you. Just go ahead and create one. It's really easy. And then go ahead and follow me, CCNA Daily Tips. Thank you guys for watching, and I'll see you on the next one. Bye bye.